the customers should be able to as well. Excuse me. If we cannot run our tests, then we're blocked and so forth. We're inefficient. Then we would expect that would affect our customers as well. And then finally, do we test what we said we were going to test? This concept of the test basis. Some of you probably heard me use this phrase on previous webinars. With a test basis. The test basis is just simply that which your tests are based upon. And have we tested all that? If you're doing requirements-based testing, have you covered the requirements? If you're doing risk-based testing, have you covered the risks? It's quite possible that things could look good in terms of quality and progress and efficiency, but maybe we're testing the wrong things. And this is actually a fairly common problem. It's misalignment of the testing strategy, which set out what we were going to test, what our test basis was, and then the testing techniques, which got disconnected from the strategy. So we'll look at some charts in just a minute that could prove useful in creating this status report, sometimes called a test dashboard or a balanced scorecard or something like that. It's balanced in the sense that if you cover these four things, it should be difficult for a situation to arise where project is going poorly, but it appears to be going well based on the indicators. That's what the balance helps you do. It helps you not miss anything. And these four areas do tend to be in balance. The consistency is helpful, as I said before, because what you want is for you use these charts over and over again. You're going to refresh them with the latest data, and people will become familiar with how to read them, and it won't be confusing to them as to what do these charts mean and so forth. Okay, so let's start with one here. Pardon me, I'm going to take a quick sip of water. All right, better now. So this is a fairly typical graph, though it is a rather information-dense version of it. This is sometimes called the convergence chart or closed, open-closed chart or found-fixed chart or something like that. It is looking at the relationship between bugs found and bugs fixed, basically. And what we have here, we've got 5 pieces of data. And 5 sets of data. And 2 of those sets of data are graphed over here against this axis, and 3 of the sets of data, the other 3 are graphed against this axis. And notice that this axis over here is a tenth of this axis over here. You see that? It's a tenth, exactly a tenth less, which tends to exaggerate the 3 data sets that are being graphed against this axis in comparison to the 2 that are being graphed here. This is a trend chart, so it's showing a trend over time. The x-axis is time. We start with the date that testing started, and we run the end date out to the date on which the testing is supposed to end. We can see the testing in the context of where it's going. Okay, so the first data set is graphed against this axis over here again, this guy. This is the total number of bugs that have been reported to date here. I'm just getting a little mouse misdirection going on there, but that's the total number of bugs that have been reported. And then right underneath it, we see the total number of bugs that have been resolved. And resolved is both deferred and closed. And I realize that the label over here says closed, but reasons of space, we're including deferred in that. This is a fairly common chart to see these 2 data sets graphed against each other. Excuse me. What we want to see in the long run is we want to see this guy go up and flop over and converge. Hopefully it doesn't look quite like that. Expect it to be a little more, I don't know, more like that maybe. And this guy, the total number closed, is supposed to track fairly closely. In other words, we want a small backlog. and then gradually converge. And it should be somewhere around the total number of bugs we expect, which in this case is 2,000. Okay, so that's what it looks like if things are going well. Let's get all that kind of fuzziness out of the way here. Okay. Now the three other data sets. We have the little pluses here, which are the average number of bugs closed on a daily basis, calculated week by week. So what that is you count up the number of bugs closed for the week, total for that week, divide by 7. It's calendar days. And a little minuses down here. These are the total number of bugs opened. And we add up the number of bugs opened for the week, divided by 7. And that's the number, a little minus there. That's the average number opened for that week. And this guy up here, these little asterisks, is backlog. Now, the backlog on any given day is the total number of bugs that have been reported minus the total number have been resolved. So we can calculate that, the backlog for each day, add that up, divide by 7 for the week, and that's our backlog. And you can see that the backlog really got out of hand here. We got into the second quarter of the testing period. Starting to get back under control, but not a happy thing. This is something we want people to be aware of. Okay, so that's bugs. You might decide to use something a little less intense than this, but it's give you some food for thought. Now, efficiency, progress. You got a test team. Test teams of a certain size. Each of those testers, on average, will spend a certain number of hours per day testing, actually running tests during the test execution period. This is sometimes referred to by management consultants as the on-task time. How much on-task time do you have? And believe it or not, it's fairly typical for a full-time employee to only have about 50% of their time spent on task. Now, that does not mean that they spend the rest of their time screwing off, but what that means is that there are just natural process overheads, meetings, emails, et cetera, that interfere with someone's ability to sit down and focus on their main job. Now, with contractors and outsource testers, you can sometimes reduce this, by reducing the overheads. And of course, you can tell contractors and outsource folks, hey, look, I don't expect to pay you for the hour that you spend slogging through emails that are not related to our project. That's your own time, somebody else's time. But even so, my experience is that you're lucky to be able to push that on-task time above, say, 2/3. We see, the 9 to 10 hour day test contractor, pretty typical to get 6 hours of actual fingers on the keyboard testing time. So I can take that average on-task time on an hourly basis, multiply it by the number of testers I have assigned in a given week, and on a daily basis, that's the planned hours. So we see that here in the dashed lines, and you got a team there, and then we added somebody, it looks like. Guys are, this is their time running tests that we expect per day. Okay? Now, the gaps in between, by the way, are the weekends. We're not going to plan for the weekends. We might have